Well, hello everyone, and welcome back to lesson 3. Today we're going to learn about how to measure the volume of something using a technique called water displacement. Okay, I'm going to say that again. Measuring the volume of an object using the technique called water displacement. Displace means to move away or to push out. And so by the end of this lesson, you'll be able to measure the volume of weirdly shaped objects using this method. So let's begin. I skipped ahead here. You may remember from math class that you can measure the volume of different objects using just math, right? For example, the page that we're looking at right here, we've got a cube, right? And we can see the measurements of the cube, right? And if we remember from math class, there is an equation that can tell us how much space this cube takes up in the universe, right? Because remember, volume is how much space something takes up, right? This cube looks like it's 10 centimeters long, it's 10 centimeters wide, and it's 10 centimeters high. So our math equation says that this cube's volume can be measured if you take the length times the width times the height, and for this cube, that's 10 times 10 times 10, which equals 1,000. So you could say that this cube takes up 1,000 centimeters of space in the universe, right? Every object takes up a different amount of space. And very simple objects like cubes or rectangles or those types of shapes can be measured with this very simple equation as long as you take the measurements of the length, the width, and the height. But not every object is so simple and put together like that. The universe is filled with weirdly shaped objects like rocks or trees or even this pen that I'm holding in my hand right here. This is a weirdly shaped object. It's not exactly a cube, or it's not exactly a rectangle or even a sphere or even a tube or anything like that. This is weird. It has a curve right here. This object takes up a weird amount of space in the universe if we're going to try to measure it exactly. But luckily, there's a way that we can do this. It's called the water displacement method, right? So let's use this example that's about to pop up on your screen. Over here, you're looking at a bolt and a little bit of water inside what's called a graduated cylinder. Now, the bolt is not in the water currently. The water is just sitting at, I'm going to call it 30 milliliters. I can't really see, it's a little blurry, so I labeled it 30 milliliters. There are 30 milliliters of water in the graduated cylinder right now. The way to measure the volume of the bolt is very simple. All you need to do is drop it into the graduated cylinder. And you probably know this from taking baths or from jumping into a backyard pool or something like that. But when you enter water, the water level rises because you're displacing the water. The water's not going inside of you, you're pushing the water away from you, right? And so when we put this bolt inside the cylinder, it's going to push the water, and the water has nowhere to go but up, right? And so you can see that this first line, this is where the water started at 30, but when we put the bolt in, the water moved all the way up to 35. Okay, now that difference of 5 milliliters is the volume of the bolt, because there was nothing else that pushed the volume of the water up, or nothing else that pushed the water up. It was just the bolt that pushed it up 5 milliliters. So however much the water moves up, that is the volume of the object. And this could work for tiny rocks. This could work for maybe like an eraser. This could work for any type of object that you can fit into a graduated cylinder. Or if you had a different measuring glass device, you could watch the water rise up as you put objects into the water. That is called the water displacement method, and it's great for measuring objects that are kind of weirdly shaped, or you could say irregularly shaped. Now, check this out. To sum up, we can use the water displacement method to measure the volume of weirdly shaped objects. To do this, you need to note, to do this is to note the amount of water with the object outside, place the object in the water, and then note how much the water goes up this is the volume of the object. All right, go ahead right now, complete the practice worksheet that's in your binder with very similar examples that you learned in this video, and we're going to try to practice this first using worksheets, and then you'll move on, come and find me for your mastery check as you demonstrate the water displacement method on real objects located near the graduated cylinders in the back of the room. All right, good luck. All right, now I gotta pause this. Here we go.